Hey, welcome back, guys. So listen, there's a phrase I'm going to throw at you, and you're going to hear about this type of business model happening more and more and more. There's cases where I agree with it. There's cases where I don't agree with it, but we're going to talk about it regardless. So climate as a service is the phrase. So we're going to speak to John Zimmerman. John he's an engineer, and he's got a business called Harvest Integrated. Now he's in the cannabis grow op sector, I guess you could call it. And what John does is his firm designs the retrofit or brand new systems for cannabis grow operations. Now, when they design it and maintain it, and they also maintain it, install it, and service it. So when they do all that, there is a fee per month to have the equipment. So the owner of the building or the business that's growing the cannabis, they are not paying whatever it costs for the equipment. They're not buying it. They're not paying someone to install it. They're not paying for the service and maintenance. They're basically paying for climate as a service, which is a monthly fee that's set for like a 10-year period, for example. And it's the same fee every month. And what they get is the equipment. They get it installed. They get it maintained and serviced, and they get the facility monitored as well. So it's a business model that seems to be growing across North America. All right. So this conversation here, it's more along the lines of business. It's more along the lines of design, because he's an engineer. He's not a technician, John. But what I have asked is that his technician that he works heavily with, that monitors the sites, maintains and services the equipment, we have a conversation with him as well, so we can get a little bit deeper into the weeds when it comes to the technical aspect of a cannabis grow op when it comes to HVAC. So as I said, guys, this is business, this is design, but you can learn from this, and you can learn how this industry is changing with these new business models put in play, like climate as a service. So let's go. We got John Zimmerman from Harvest Integrated, guys. This is the HVAC Know-It-All podcast. I'm your host, Gary McCreadie. Top contractors across the U.S. only. This one's going to be pretty cool to expand your marketing reach. Property.com is an exclusive network for certified pros. You can get your own custom Property.com webpage for free. You can also get AI-powered reputation management and get some great lead generation and prospecting tools. The Know Before You Go tool is pretty cool. It gives critical homeowner data like how much they've paid on past jobs. Join Property.com's exclusive network now to expand your reach with homeowners across the U.S. Use McCreadie.property.com. So that's MCCREADIE property.com to fill out the form to get approved. All right, John. So indoor grow is something that is over the last decade or so, it's become more of an industry niche, especially from the HVAC side, because the environment needs to be maintained very, very well in different applications. So I guess at a high level, we need to talk about the environment, the way we're going to control it, like with what equipment, how we're going to do it, the control devices that need to be in play, like humidity, temperature, all that kind of stuff. And let's just talk about that in general, and then we can get into the business that you're in and how you help people in this industry niche.
Sure. Yeah, not a problem. So prior to jumping into this industry, myself and my team, most of us were really focused on data centers and providing data center cooling. So we really like to try and draw that analogy to data center facilities with these facilities in terms of HVAC design, NDP design, really. And kind of, if you were boiled on down to just kind of one statement, you would like to say that these are basically data centers with a pool in the middle. What we mean by that is that you've got high density heat loads, you've got high density power loads. We're talking about a critical environment, so 24/7 operations. If they lose a crop, you might be talking about losing an entire business. And so we really kind of use a lot of the same principles we learned when we were designing and building data centers, especially in terms of HVAC. The only difference being, and it's a major difference, which is the humidity output from the plants. So these plants typically transpire or sweat somewhere around 90 to 95% of the water that they're being fed. And you're talking about anywhere from a half a gallon up to a gallon per plant, depending on who the grower is, the type of strain that it may be.
And when you say a gallon to half a gallon, are you talking, and what time period is that?
Sorry, yeah, per day.
Per day.
And they'll have different regimens on how they distribute that, how they give that to the plant. But the long story short is it's a critical environment that you've got to keep everything operating properly because it's got such an impact on the quality of the product that our clients are trying to produce. And then you got to consider things like redundancy and proper redundancy, as well as indoor air quality, those types of things. So yeah, that's kind of the general high level of the need in the space in terms of HVAC design.
Okay, cool. Now let's go back to, you said data centers, and I have a lot of experience in data centers because when I started in the trade, I was installing a lot of VRF for data centers, Liebert systems, stuff like that. Then I moved from installing them to becoming a service technician, and I did a lot of the data centers that the company that I worked for had at the time. And I really enjoyed data centers. I enjoyed data centers. I shouldn't say I enjoyed all data centers. I enjoyed the data centers that were built properly, designed properly, had the redundancy. There was one data center that I think of now. There were 7 30-ton Lieberts in there. I could shut 2 of them off, maybe even 3 if I got lucky, and we would still maintain temperature in that space. And that's the amazing part about redundancy is that when you design it with redundancy, you can have downtime. You can make repairs to one unit and not worrying about bringing in fans or extra machines. You're not having the IT guys breathing down your neck. Hey, when are you going to be done? All that kind of stuff. And it's a clean environment. It's inside. It's comfy, cozy in there. It's nice and cool. Like on a hot summer day, you walk into it's dehumidified. It's nice and cool. You're working in an environment where you're not on the roof or in an attic or something like that. So I really enjoyed them. The ones I didn't enjoy were the calls where they didn't have redundancy, but they were told they needed it. And you get there, it's down. The room's 90 degrees. The servers are shutting down. They got fans. Everybody's panicking. And I used to panic. I used to panic all the time. And I'd walk in and I'd be trying to rush and get things up and running really, really quick. And I started to understand that it's really not my problem. It's my problem to fix it, but it's not my problem to share their anxiousness or their anxiety, because it's not my fault that I didn't design it right with redundancy. So if I get there, hey, it's going to take the time it takes to get it fixed. I can't make this go any faster. Next time you guys put in backup. So just talk about the redundancy portion, and we'll obviously talk about the grow room situation, but because you said data centers and you've got experience, I wanted to pull that out of you. How important is redundancy in these types of applications?
Oh, it's critical. I mean, hence the term, critical environment. So when we got into this industry, the cannabis industry, the grow industry, if you will, we had to kind of look back on the things we did in the data center space. So in data centers, you could have some clients who need heavy redundancy looking at 2 ends. So if you have 4 units that are covering the load, they want another 4 units there just so they could shut all of them off and still keep the room online. In less critical environments than that, you may have N+1. So if you have 4 units covering the load, you just need that 5th there in case one goes down or you need to turn one off, whatever it may be. When you get down to it, what we're talking about in terms of redundancy is we're really talking about the client's risk level and what they're willing to tolerate, right? And then in addition to that, it's, all right, well, exactly what is the risk that's going on here if something goes out? So we've told clients in this industry that these aren't servers that are going to die if you lose cooling within 5 minutes, okay? And those servers may be servicing something along the lines of credit card transactions or 911 call centers, whatever it may be. So I would call that hypercritical. You almost are getting to the point of life or death, depending on how much redundancy may be there. But a plant's not going to die within 20 minutes, 30 minutes of losing cooling. So as an equipment salesperson, I would love to sell you more equipment, Mr. Owner. But the way we would approach it as designers, and really just because we like to shoot them straight, is we have the ability to where we could, header all of your supply air duct between the rooms and isolate those off. And if one unit goes down or a unit goes down in a room, we can open up that damper. And now you have more or less N+0.5 because most of these guys are kind of getting pushed into having one extra unit. They're not exactly sure how much capacity they have if something goes down. So we really try to give them options. But in the end, without redundancy, you're really just leaving yourself up to chance, and you're leaving yourself up to somebody who may come in and say, hey, I'm not the one who designed it this way, so therefore it's going to take what it takes. That may be so much that they lose a crop, they get mold in the space and have to remediate it. And that may be enough to really hinder the business, to really put them out of business. So while it may not be exactly as critical as the data center space or as data center facilities, it's still very critical, and it is absolutely something that needs to be addressed in these. These are critical facilities at the end of the day.
Yeah, for sure. Now, I don't work in grow situations. I would love to, because I like to experience things at a high level in the industry. Like, I've worked on machines like a Dectron, which is a pool dehumidification system, which can reheat pool water and heat the space, cool the space, but also dehumidify the space too, because obviously you have a lot of humidity in an area that's got a pool in it. So I enjoy that type of equipment. Now, because I don't know much about plants and the cannabis industry and how to grow it, like, we have different stages of the plant, right? So did those stages of the plant growth have different environments?
They do, yes. So if you go all the way to the, kind of very beginning, you have, you're either getting most of these guys are getting their plants from what are called clones. These are small clippings from a mother plant, and they'll have all these clones kind of sitting in a room, and they're different strains that they're going to be populating inside of the space. So they'll pick those, and when they start growing, they're in what's called the vegetative phase. So that first phase is very immature plants, so they're not sweating as much. They're not producing as much humidity, so you're probably more in like the 0.8, 0.9 sensible heat ratio range with those rooms. After 2 to 3 weeks of that, they move them into the flower room. The flower room is kind of what you've seen in terms of pictures of what a grow room looks like. They'll stay in that flower room for upwards of about 8 weeks. And actually, we've had clients who will have kind of different humidity and temperature set points that they're looking for each week of that flower period. And then what you get at the end of that flower period is the last 2 weeks. Most of these growers like to do what's called a flush. And so they will try and drop that temperature in the room down to, say, 70 degrees. And they try to drop the humidity down to, say, 45 to 48%. Sometimes they're looking for conditions that just physically you can't meet without freezing up a unit. So we got to educate them on that. But that last 2 weeks, they're trying to pull a lot of the terpenes out of the plant. They're trying to get a lot of the color out of the plant. I'm not a grower myself, so I don't want to go too far into that realm there. But so then you got to deal with that kind of at the end of the flower phase. And then once they harvest it from the flower room, they have to do a dry and cure period. So that dry and cure period, what you want to do is in the first couple of days of that period, you want to remove 50% or so of the wet weight of the plant. So you've got the first 2 days where you're dehumidifying and you don't have any lights, so you really don't have any scents below, but airflow is a big deal when it comes time for drying. So you need, so depending on who it may be, anywhere from 10 to 20 air changes per hour. You need great filtration that's in there. But what happens in the dry space is you really need to have a unit there that has the ability to heat and cool, to dehumidify and humidify. You need to be able to kind of manage that environment exactly the way it needs to be. So if you need to add humidity to the room, there better be a humidifier nearby, which is generally not top of mind when people are looking at this space. But it is critical because in that drying phase is, you're kind of producing that finished product that's going to go sit on a shelf somewhere. So yeah, you will have different units and different designs for the vegetative room, the flower room, and then the dry and cure room. And then within that flower room, you may even have, anywhere from 2 to 4 different kind of phases that require different set points and different humidity levels. So yeah, it's, in my opinion, it is one of the more complex HVAC designs that is out there. And that's kind of what's created this environment for our company to come in and say, hey, we see a lot of you have kind of scaled up what you were doing in your basement. And while you got 10 tons in that unit, that 10 tons is really designed for dry air in an office building, not for humid air in a critical environment. So it's caused this kind of gap of expertise that we're able to kind of fill in.
Tell us the loads that we need to look at heavily where do these loads come from? So the plant, yes, you said it lets off 90% of the water that it takes in. There are lamps. I don't know if there's like people. I don't know how many people are in a grow operation, but what are the loads that we're looking at when we're designing or sizing up a piece of equipment for a particular room?
Sure. So let's start with indoor. That's pretty easy. Static, I would say. You're basically talking about a sensible load coming from the lights. That is, if not all, that's probably 95% of where that sensible load's coming from. And then you're talking about the irrigation that's being fed to the plant. So whatever irrigation that's going into that plant, we've got calculations on how to determine what it's going to sweat. But if you're growing indoors, what you're talking about are basically lights, and you're talking about the irrigation, and that's going to more or less create your total load. I draw a distinction here because then you have greenhouse and you have sealed greenhouse, which we've done those as well, and we've designed those as well. What's different there is you're really talking about the solar radiation. So ASHRAE states that roughly, 50% that once the solar radiation kind of penetrates the window or the glass of the greenhouse, you can estimate it to be around 50% will turn into latent, 50% will turn into sensible, and that's a good rule of thumb for sure. But you're definitely dealing with something different in terms of the sun and the solar radiation, and then you've got to if there's too much sun one day, if there's, not enough sun one day, these guys will have curtains that they've got to pull, and the systems have to be able to react to these things.
Gotcha. Okay. So your business, Harvest Integrated, can you just tell us what that is? Like, are you guys manufacturing systems, designing systems? Like, just give us a breakdown of what you guys are doing.
Sure. Great. No, we do what's called climate as a service. And what we mean by climate as a service is that we will buy, own, operate. We will repair if needed. We will replace if needed. The entire system, all in exchange for a long-term agreement with a monthly fee to our clients. We really kind of took a page out of the data center space again with this. We actually took a data center agreement between a data center developer and the tenant, because what we wanted to do was create a business model that our clients knew gave us an incentive to really have some skin in the game, right? So one of the things we've took from that is that, all right, we'll put in the agreement what the design set points are that we are going to maintain. If for whatever reason the room gets out of those design set points with a little cushion on it for an extended period of time defined by the agreement, we're on the hook for paying you, Mr. Client, what's called service level credits that we will apply to your next month's bill. Because what we learned in this industry is, try to put this delicately, the procurement process was not as formal as you might be used to, say, in the data center industry or most other commercial industries. You would have anywhere from a situation where an owner bought units thinking that they had support behind those units when really all they had was a 1-year parts warranty. When they heard the word warranty, sometimes they thought that was a guarantee. That's not what it is. When they heard the word warranty, they thought, oh, okay, parts and labor. And, as we kind of know, most common, what you'll see is just a 1-year parts warranty with a lot of this stuff. So inevitably, we'd be talking to clients who would, man, I can't get my units up. They keep crashing. I can't call people. They won't come and help. And so we wanted to just create a model that more or less checked all the boxes that they were looking for with all the problems they were having, starting with capital, starting with getting it designed properly, and then operating it properly. And if something's going wrong, that you don't have to figure out who to call. Half these guys don't know who to call when it comes time for that.
I get what you're saying there. So tell me how, like, let's say I'm a client and I have a grow operation that I'm about to start. What is like so if someone reaches out to you, is it first we go into the design process with the client? How does it all work?
Yeah, so that's exactly how. I mean, it works very traditionally where if it's a new build or an expansion, we're going to get a call and they're going to ask us, for a quote on the equipment. And like I said, we do what we call climate as a service. So right off the bat, what we'll do is run loads just by getting their irrigation rates, getting their light count, their loads, the heat loads. We'll be able to produce a proposal, at least an upfront proposal from that. But then we have to really visit the site to kind of find out, is the ductwork big enough, or do we have enough space for this ductwork? Do they have enough electrical capacity? Now I'm kind of getting into more of the retrofit phase because we serve both the industry there.
Oh, you serve both sides of the industry. Okay.
That's correct. Yeah.